Hi, so in this video I will be talking about how to create a modular game architecture in Unity with Scriptable Objects. The reason I'm making this video is to share my knowledge of reading this book. It's published by Unity. It's an ebook available in their forums, and before reading this book, the only thing I knew about Scriptable Objects is to use them for storing shared data. We have 5 different types of entity, and we need a common shared data among those 5 instances of entity. Then we make a scriptable object and store the data of this entity, like speed, damage, etc. But after reading this book, I realized how powerful the scriptable object is and how awesome it is to create modular game architectures. I've implemented the scriptable objects in various projects, but I will discuss this Rangers project that I have posted a lot of videos. In this video I will be specifically discussing about how I implemented the scriptable objects parts to make factories, to make event systems, and to use them as data containers as well here. So let's see, and also event channels. Let's see how we do it. So we can see that scriptable objects can be used in various places where mono behaviors are not needed. It can be done with mono behaviors, but if we do it with scriptable objects, it will help a lot more for referencing in editor and also changing various types. We will see how scriptable objects are used as data containers, which we know obviously when we use the flyweight pattern or when we use shared data among various instances of an object. We will see extendable enums, so rather than creating enums, how we can use scriptable objects to create those enum types, and how easy it is for any extension of those enums. We don't need to change codes, rather we just duplicate the enum type asset of scriptable object and use that. We'll see how they are used for delegate objects, how they are used in observer patterns, in comments, in runtime sets. I like this very much. Let's see. So this is a simple scriptable object creation, and this is how we reference it. But then what we can do is we can store them in variables, and dynamically create or destroy them, pass them as arguments, return them as a method. Can do all these kind of things. We just don't need to only use them as storage and reading data. But we'll see why we need to do this. So we can also serialize for saving and loading, and all these things we can do. And now here is some comparisons. This book is really good in explaining what they can be done. This is how we serialize and deserialize, life cycle. Let's see how we can use this as data containers. Typical use cases are inventories. So inventories is something that changes its contained data at runtime. We can also use them as item statistics. So we have player which need to have its statistics. We can use them for that. Audio collections. We have different audios. We can use scriptable objects to store those audios and play them when needed. So this is a good differentiations: scriptable object versus persistent data. And so this is the flyweight pattern that we generally use scriptable objects for. We have multiple instances of an object class, and they all can have data if we directly add the data's best properties inside the class. But if we use a simple scriptable object, then it can share the data among those objects. This is the basic implementation we do all the time. But other than that, there are also various use cases. These are the benefits. We can use these. So if we change the value inside scriptable object in play mode, it will stay. That's really helpful. And now let's see. So we can store the health inside the scriptable object, which just stores a simple int value. And now we can just duplicate the asset, and we can create a health. We can create a damage, other things like coins collected, gems collected, current speed, various data that can change at runtime and also need to fire an event. Now, this thing is not firing any event, but if we add a event here, whenever the value will change, we fire the event. Then any other class or anywhere who listens this event can instantly get the new value. That is called observable data containers. So let's see the extendable enums. Okay, first, these data containers I have used in Tank project to create the tank data. This is a scriptable object. We can scroll up and we can see that all these data, yeah, airstrike data. So all the instances of airstrike will have this shared scriptable object. We have these tank data. All the instances of green tank will have this shared data. These are not changed at runtime. These are persistent throughout the game. So that's what data containers means. We have player data. Now let's see the extendable enums. In this case, we just have like this, an empty scriptable object. Now I call it generally a tag SO because it works as tag, paper, rock, scissors. In my tank project, I have different tags like airstrike, auto target, invisibility, self-seed. These are ultimate tags. These are the tank tags, red tank, blue tank, yellow tank. Simple tags. These are primary action tags, charge, Tesla. We'll see why it's so helpful in creating it. And this is the tag SO. As you can see, it's the same. There is nothing else written in empty scriptable objects. So here the simple rock, paper, scissors game has been created using it, and it's very helpful. You can see we can also add logics in it, and these logics can be different for different objects, and that's also very helpful, extending the behavior. And then if you read here, you will understand how this logic is helping. Next is the delegate object. So delegates versus events. So it's a very important place in observer patterns. We can see how these methods help. So we have an unit, then we have its logics written here. Suppose we have an enemy which my project is not sure how the enemy will move. So I created two separate scriptable objects. One with the enemy will keep jumping and moving. Another is the enemy will just fly. So I want to test those two. I want to test those two movements one after the other. So in my enemy unit, I can drag the scriptable objects while it's jumping. I will reference it in the editor and then play. The enemy will jump and move. And then I want to also test the fly thing, so I will just reference it in the editor. I'm not changing any code. That's the power of it. Just dragging and dropping in the editor for testing. Or even I have another script that will give this reference automatically, as in strategy patterns we have seen. And then modifying the scriptable object data. It will persist if we modify it. So if we don't want that after the game ends, we can have a reset method that will reset it when the game starts. So yeah, we can see the enemy AI. It can patrol, it can flee different states. And this way it's very, very, very modular. Okay, then we have audio delegates. So this is how the audio is. So now if we duplicate the asset, we create an instance of this and then we duplicate it, and then we will get a lot of audio files, and whenever we need to play, we can just have reference of these files, these assets. It's very well detailed in the book, and this video is really good to actually understand. There are all the examples given how to work with them. Next is the observer patterns. I have also implemented these event channels are just random events channels. I have created here some event channels. You can see, so charge update event channel. So any tank which updates its charge can call this event with it's an int event channel, so it will also have a parameter of the charge amount. Player health event channel. Well, it is an int event channel. That means the left one will be the current health and the right one probably the max health. And player ultimate assigned is just a tag. It will notify the UI of the player which player has been assigned, ultimate has been assigned, by sending the tag of it. So we can see in here how to avoid singletons and how to create these events, because they are so modular. As you already have seen, scriptable objects aren't just for handling data. They can contain methods just like any other scripts. Okay, the observer design patterns. So this publisher and this subscribers, this publisher can be a scriptable object, and these subscribers can have reference of the scriptable object in the editor. In this way we can easily communicate. Here we go. The publisher will have so this is a separate event channel, and this. So if we don't want this publisher to if we don't want this subscriber to listen to this publisher, we don't need to change any code. All we can do is remove the reference of this event channel from this subscriber. The rest of the code will work. That's how powerful it is. If we don't have these scriptable objects, we need to have a reference of the publisher directly in the subscriber. to register to its events. But now this works as a middleman. So if we cut out one of these listeners, it doesn't affect the rest of the code. That's why I have made these same way to help mine. Okay, it has an event raising method. So let's see the void. So we can see that it has an event, and then it has a method to raise the event. A publisher will call this method, and the event will be raised. The listeners will listen to this event. Okay, that's how it works. If we have an Unity action, we can also have those event channels. Like if we made this rather than system.action to Unity action, we can directly reference those events in the editor itself. The scriptable object will show the reference. So this is the exact code I've used here. Right? And you can see this is a listener that has the reference of the scriptable objects rather than having the reference of the publisher. So it's just listening to the event channel. It has no idea who the publisher is. That's the power of it. The listener don't need to have idea of who the publisher is. It only needs to have idea of what the event channel is. So it works a little bit like an event pass, mix of event pass and events. So, right. You see. You can use these to create audio management, scene management, UI management, save data management, various use cases. So the new input system of Unity uses similar way. Whenever we create a new input, we can see there's a new scriptable object of that input created. I have the input system. I've used it. So all these are scriptable objects that gets created whenever we create a new input. And we can reference these inputs directly on a script to use that input. Input reader, observer. The observer don't need to know about the actual game input. All it needs to know is the reference of the input reader, these ones. Then comes the static versus non-static. It's just what is static input, what is non-static input. Then we can use it as a comment pattern. I didn't use this directly. I didn't use this in my project, but it can be also used for comment patterns. You see, we have an interface, and then we can create various scriptable objects of commands from the interface rather than creating these as a separate class. The benefit of using this is to reference them in inspector. The most important benefit, there is not direct reference, so we can swap them according to our needs whenever we want. So scriptable objects or C# class. When deciding on the right code architecture, it's important to consider the skills and preference of your team as well as your game's performance requirements. Some designers may prefer to use the Unity editor interactively, others may prefer to work entirely in C#. Take these factors into account when creating a code base that's easy for everyone on your team to work with. Okay. So again, this is the best answer, because after all we are working with teams, so some team may not prefer this way of working with editors. So we need space to know all the possible ways and then implement whenever it's needed. Then we have the runtime sets. So these are just like an inventory details where we can add items and they will stay, and then we can use this reference of this entire asset to display in the UI and stuff like that. So yeah, then there are some examples that will really help us to understand it. So if you really want, go through them and enjoy a new way of programming. They may be not useful if your team don't know it, but surely helpful if according to that thing. I prefer it, I like it. Before knowing it, I didn't like it, like I didn't understand, so what would I like about it? But after knowing it, I really felt that it's really a great way. Even though I'm a programmer, but surely using this reference specifically helps in testing, and also it scales the project in a better way. Very useful to me. And thanks for watching.